Hi, mathletes. Today we're going to create and interpret tables, graphs, and equations. And we're going to look at a situation. So for this one, it says, for Valentine's Day, the French Club has decided to sell roses as a fundraiser. The students can buy the roses for 50 cents each. They also need to buy paper and ribbon, and that's going to cost them $60, but that's for the total supply. And then they're going to sell each rose for $1.50 each. They're going to take the orders in advance so that they know the exact number of roses to order. And they need to buy that paper and ribbon, though, regardless, and that's a fixed cost of $60. So let's start by making a table. We're going to have the number of roses, the expenses, and the income. And we're going to go from 0 to 100, but let's count by tens because otherwise we're going to have 100 rows. So the number of roses, the income, how much money they have coming in, the expenses, how much money goes out. So for roses, we'll go from 0 to 100 again, counting by tens, increments of 10. And for the income, remember that they get $1.50 per rose. So if they don't sell any roses, they don't get any income. But for 10, it would be 10 multiplied by $1.50, which would be 15. So for every 10 roses they sell, they get an additional $15. For the expenses, even if they don't sell any roses, they still need to pay $60 because that's the cost for the paper and the ribbon. And then for every rose that they buy, they only have to pay 50 cents for a rose. So for every 10 roses that they buy, they have to pay $5. So you'll see that it increments of $5. But again, initially they have to spend $60 because that's how much it costs for the paper and ribbon, but that's just one time, and then it increases by 5 each time. So now we'll write an expression, and let's use the variable n for the number of roses. So for the income, the money that they have coming in, it's 1.5 or 1 in 5 tenths n because each rose sells for $1.50. I just didn't put the 0 in. The 0 you don't need to. So 1.5 n. For the expenses, it's 50 cents for each rose that they buy. So 50 cents for your initial cost. And then the plus 60 is right here because that's how much you have to pay for your paper and your ribbon. So here we have our table, and here we have a graph. And for our graph, we have the money versus the number of roses. So the number of roses is going to be my x, and how much money I get is my y. So here's my x, and these two are my y's. So I plotted my income using the blue. So again, counting by tens, so 0, 0, 10 to 15, etc. And I can draw my line. For the expenses, I started at 60 because remember it costs $60 for the ribbon and the paper, but then it increased by 5 each time. Again, plotted the points 0, 60, 10, 65, 20, 70, etc., and drew my line. So how many roses will the students have to sell to break even? In other words, not make money or lose money. And that's going to be where the lines intersect. So at 60 roses, so here's 50, and these are increments of 60, so 60 is where they break even. So that's where you can see it on the graph. It's where the two intersect. If you wanted to see it on the table, it's where the income and the expenses are the same number. So both at $90. So that means if it's at $90, they sell $90 worth of roses. That means that they paid $90 in the expenses. Explain how you would calculate the profit from the graph. Well, if we look at the graph, we could use the ordered pairs. So when the x is the same, we subtract the two y's. In other words, the income minus the expense. If the difference is negative, you've lost money. For example, if you're looking at 40 roses, you would say from the graph, look at the 40 roses, and you'd say 60 minus the 80 is a negative 20. So again, here's your 60 and your 80. If you wanted to look at the table, you could look at the number of roses. And in the income column, look at the number of the expenses. So if I look at, for example, for 80 roses, I could look at the income is 120, the expenses was 100. So in this case, I made money. I made $20. Now we can also explain how to calculate profit using equations. So that's the income minus the expenses. So we can combine our previous expressions to create an expression for calculating the profit. So our original expression was that income is 1.5n and expenses was 0.5n plus 60. If we put those together and we want to say the 1.5n, remember we're subtracting the expenses. I put this in parentheses because we're subtracting the entire expression. So the 0.5n and the plus 60, we're subtracting the whole expression. Now, let's use our expression for income and expenses to calculate the profit for 50 roses and 190 roses. And again, we'll let n be the number of roses sold. So if I have 50 roses, I have my expression 1.5n minus 0.5n plus 60. I replace both n's with 50. And now I can simplify. 1.5 multiplied by 50 is 75, and 0.5 multiplied by 50 is 25 plus the 60. 75 minus, and the sum of 25 and 60 is 85. So I end up with negative 10, which means I have a negative 10 profit for 50 roses. It means I have to pay $10 to sell 50 roses. So I need to sell more than 50 roses. Let's look at what would happen if I had 190 roses. Again, using the same expression, but this time we're going to replace our n with 190. I get 285 minus 95 plus 60. Again, I'm going to simplify in the parentheses. So I get 155, and when I subtract, I get a positive number of 130, which means I made a profit of $130 for 190 roses. We can also write a simplified algebraic expression for profit. If we let P equals profit and N equal the number of roses sold. So P equals, and this is the same expression that I used here, but now I'm writing an equation because I have my equal sign. When I notice this, what I can do is I can simplify this by multiplying in the parentheses, 0.5n plus 60 by negative 1 because it's minus the entire quantity. So I have negative 0.5n and negative 60. So P equals n minus 60 because 1.5n minus 0.5n is n. And that's very simple compared to this, so a simplified version of it. So now let's look back at our graph and look and see which line is the steepest and why. Well, when I'm looking at the income, that's the blue, it's steeper. And again, its coefficient is bigger. Remember, coefficient is the number in front of the variable. So in this one, the coefficient is 1.5. In the expenses, which is the red line, the coefficient is only 1/2 or 0.5. So the bigger the coefficient, the steeper the line. So the rose is being sold for more than its cost. Where do each of the lines on the start of the y-axis, and why is this the starting point significant? Well, when I look at the blue line, it's starting at 0. And 0 is the income. And the reason it starts at 0 is because if you don't sell any roses, you're not going to make any money. But notice the expenses. The expenses start at 60. And that's because even if you don't sell any roses, you still have to pay $60 for the paper and the ribbon. So this is how we can use linear functions to help us solve everyday problems. I hope this helped to clarify it for you. And it was kind of fun too.